Welcome back. We'll be looking at trigonometric equations today, and we're going to tie it into the sine curve and the unit circle, and we'll see what we can do with this. So let's go ahead and get started then. If we take a look over here with this thing here, it says the equation, the sine of x equals k, and then k has to be in between plus and minus 1, that it would have the solution of this one here and that one there. And n is the number of times you're going around the block, if you want to think of it that way. When we get to the unit circle, we'll be seeing that every time you go a complete run around the circle, you will have passed by the solutions that you have been finding. And you can go around the block as many times as you want. So this would be the equivalent of finding all of the solutions. Okay, so let's run over to the unit circle. I've only put out the ideas. You understand by now that it's either 360 degrees or 2 pi for a complete trip around the block. I just didn't want to get cluttered at this moment. All right, so if you have a particular sine x with a value of k, so, I don't know, say the sine of x is equal to a half, you would go try to find the places that made that true. So that would be in the case where you have, say, if this was a half high, and that could be a half high then. And we would want the positive value in this case. Now, let's continue. That's the general idea, that they can be separated. You know, as a sine curve goes around, that there are places that can be higher or lower, and that it also means, unless you're exactly on the top or the bottom, that you'll get two solutions to that, or two places where it's true. So that's what we're going to be doing right here. We're just looking at what this actually says physically. So if we have, say, right over here, this red one right there, and like I did before, if perhaps that was 45, you'd find it here. Well, maybe not in this case since I drew it above a half there, but the idea is wherever you have your particular angle, you look up and you see, okay, I can read it off, and then I just follow the same y equals k line until I get to the other one and come down. Now, sometimes you can't read it right off of a graph, but a calculator can help you out, and so can other programs that draw them. But if you have something other than where the sine of x equals 1 or minus 1, you will get two places that reflect it. And then you need to use this, because you need to remember that wherever you are, you can go around the block and come back to it. And since you're starting off with two places that can fulfill it, you need to think to yourself that, well, we're going around the circle. Okay, that's really important. So knowing that, let's go ahead and solve one as a little example. And here we have an exact solution. So when you see exact solutions to begin with, think, okay, I can go to the graph of the unit circle and try to get some help there. But let's look at the idea first. There is what we were given first, and we know that whatever x is in degrees, when we go there, we know that we're going to be looking for a second one as well, because in this case, this is not equal to 1. So we expect to find two solutions, and that's just illustrated like this. Okay, but let's look at the unit circle chart. And when you are using this chart, you need to remember a couple things. So let's just bring it up. Okay. Now, I know it looks rather intimidating, but don't let it frighten you. We had this, and we had this over here, because we knew, let me just back up for 1 second. See that? The square root of 2 divided by 2. So let's go back over here. Remember that it is the sine that we're after. And remember that these coordinates gave you the cosine and the sine. And if we have a little triangle, let's just pretend for a second that this is the one that we're looking for. Say that it was for 45 degrees. The sine would be this one, okay? And that's in the y direction. And what comes first, x or y? Well, this is x, the x-coordinate. This is the y-coordinate, okay? That's real important to remember. And if you're drawing your triangle over this way, looking at it like that, okay, just remember it's the angle that goes all the way over like that, okay? But you'll get the same value for those two. All right, that being said, let's go ahead and plop in those numbers then. We found that it was 45, and let me just back up one more time. See, clean it up one more time just so you can look, because this is really important. All right, you can see this here. We were looking right there, and there's the 45 degrees. If they were asking for radians, we could have done that too. It doesn't matter. And just remember, it's the sine of x. All right, can never be I can never say it enough. The unit circle is very, very important, and you'll have to get used to just reading it. And when you find ratios like this, go there and look. You'll find that there's quite a number that are there. All right, that being said, let's go ahead and mark everything so that we know what we're looking at. Remember, as the sine wave starts, it comes up, and as soon as you hit the 45-degree mark for x, that's when you'll get this value. And then as you go up the top and come back down, you'll end up over here. And that's just what we expected, because we were looking carefully at this one right over here. Okay, there's the 135, there's the 45. Okay, so there we have it. Now we can just continue and clean this up a bit. Remember, the first part, we wanted to get all of the solutions. So obviously this is a solution, but then you can go around the block, and n is a whole number. So if you say, okay, we're going around a whole nother turn, then you could say, well, let n equal 2 and 3 and 4 and 5. So how many times do you want to spin it around? Okay, let's go with the other one now. There we go. And remember, we had this one here. This is for the second position. That's why that's there. And that cleans up to 135 n times 360. Okay, and remember, the 135, that was the one that we found over here. The 45 was there. Okay, so when we show our answer, we need to show the complete solution. You'll find a solution there, no matter where you go. That's right here. And you can spin around the block as many times as you want. You'll always end up in the same spot, and that will give you the correct value right there. And then for the other one, this here, that was at the position 135. And again, go around the block as many times as you want. You'll always end up in the same spot if you keep having multiples of 360. Okay, hope that helps you out. See you next time.